Okay, here we go. Today is about solving absolute value equations. And remember, there's a big number line on my wall, but I know you guys aren't there right now, so I wanted to remind you what absolute value is. Absolute value is just simply talking about how far a number is from 0. So let's say we were here at 3. Obviously, 3 is 3 away from 0. But if we were here at -3, that is also just 3 away from 0. It's talking about just how far it is from 0. It's not talking about a negative. So absolute value is always going to be a positive number. All right. Whenever they're talking about absolute value, it's always positive. Distance is never negative. Okay. So take a moment, like usual, to do the warm-up and come back and check your answers. It's going to be a good review of section 6.4 and do that. Okay. Okay, so here you go. These are the answers. It says for A equals -12, find -A and the absolute value of A. Well, to find -A, you had to stick -12 in for A, and it looked like this right here. You have -12, which would make it a +12. That's why I wrote this here. -A actually equals +12. It's kind of a weird concept, but think about it for a minute. And then the absolute value of A, you stick it inside the absolute value bars. And this simply means how far is -12 from 0? It's 12 spaces. That's why it's positive. All right, here, evaluate. So again, I had to stick in -3 for x, which is inside the absolute value bars. The absolute value of -3 is +3, so it's 3 minus 2 equals 1. The change in elevation as a diver explored a reef was down 0.5 feet, then up 1.5 feet, then down 2.5 feet, and then up 2.25 feet. Which change in elevation had the greatest absolute value? Well, you can just kind of look at these numbers and say, oh, that's only 0.5, that's only 1.5, this is an absolute value of 2.5, that's an absolute value of 2.25. So your answer would be this one right here. It's got an absolute value of 2.5 feet. We should write feet. Okay? That's the warm-up. All right, let's talk about the notes. Solving an absolute value equation. This is just kind of what it looks like in the book. Just know that if you have to solve the absolute value equation, you think about what's inside here and you set it equal to the positive version and the negative version. And I'll explain it more as we go. So before I actually show you how to solve, let's just think about what numbers could go inside there. I'm going to write it out. What two numbers could x be to make this equation true? Okay, when there's simply just an x by itself in here, that's all you got to think about. It could be either +9, because absolute value of 9 is 9, or it could be -9. So I'm going to write it like this. What's inside here could be +9, which equals 9, or it could be -9, which equals 9. So that tells me that x could equal 9 or -9. All right? Now, this one's a little bit different because we're taking whatever our variable is, subtracting 7, and then taking the absolute value to get a value of 9. So we have to just kind of say, all right, that means whatever is inside here, total, has to be r minus 7 equals +9, or r minus 7 equals -9. Because +9 or -9 is what I have to have in here in order for it to equal 9. So I'm going to figure out what r's would make that happen. So I add 7, and I get r equals 16. So this tells me if r was 16, 16 minus 7 is 9. The absolute value of 9 is 9. Here, if I add 7, r equals -2. So that tells me if I plug in -2 minus 7, does it equal 9? -2 minus 7 is -9. Absolute value of negative 9 is 9. So I have two values for r that would work. That's why you have to set whatever is inside there equal to the positive and the negative version of that number. Okay? All right, let's try that again. So whatever value is inside here has to be positive 3 or negative 3. So I'm going to set x plus 4 equal to 3 and x plus 4 equal to negative 3. So I can find out what two x's are going to make that happen. Minus 4, minus 4. X could be negative 1. Negative 1 plus 4 is 3, and the absolute value of 3 is 3. Negative 4, negative 4. X equals negative 7. Negative 7 plus 4 is negative 3, and when I take the absolute value of negative 3, it's positive 3. So these are my solutions here. Okay, if you want to write it like this, that's fine, but do not, say it again, do not make them an ordered pair, because they're not an ordered pair. It's just two separate x values, okay? All right, we're going to take this a little bit further. You can see here that we have absolute value here. It's being multiplied by 2 and has 4.1 added to it, and it equals this. It's just like solving an equation. You've got to isolate that absolute value thing right there. Isolate the absolute value. Never, ever, ever distribute. These are not parentheses. You cannot distribute, okay? So otherwise, you just do it like solving an equation. First, you undo the addition. So I got to subtract 4.1. I'm working towards getting this absolute value thing by itself. So that's going to be 14.8. It's still not by itself, so I got to divide by 2. Absolute value of s equals 7.4. Okay, so this is a pretty easy one. S could be either positive 7.4 or S could be either negative 7.4. I could plug either of those into there and find the absolute value and end up with positive 7.4. Let's do another one. Okay. All right, here I got to isolate this absolute value. So first I got to do is get rid of that minus 5 by adding 5. I still have 4 times t plus 9 equals 24. I got to divide by 4. T plus 9 equals 6. Now, I've isolated it. Now I can say, well, whatever is inside here has to equal either positive 6 or negative 6. Okay? So I'm going to find out what t values will make that happen. Subtract 9, subtract 9. T equals negative 3. Subtract 9, subtract 9. T equals negative 15. These are the two t's that I could plug into here and still have the equation equal positive 19. Okay, let's just do one more just to get the hang of it. Remember this, you're never distributing. Cannot distribute into an absolute value. So it's the same as this one. We're going to add 7, add 7. We've got to isolate that absolute value term. And then we still have 3 times the absolute value of 4x plus 2 equals 18. Divide by 3, divide by 3. Absolute value of 4x plus 2 equals 6. Now, whatever's inside here has to have a value of 6 or negative 6. So I'm going to set it up that way. 4x plus 2 has to equal positive 6, or 4x plus 2 has to equal negative 6. Let's find out what x would be. Subtract 2, subtract 2. 4x equals 4. Divide by 4, divide by 4. X could be 1. Or subtract 2, subtract 2. 4x equals negative 8. Divide by 4, divide by 4. X could be negative 2. So this tells me that I could plug 1 in here and do all this math, and the left side would equal 11. Or I could plug negative 2 in here and do all this math, and the left side would equal 11. Alrighty? Okay, turn it over. Let's do a little bit more. Okay. It says solve if possible. There's going to be a situation or two where you might not be able to solve. So let's see what happens. Because remember, absolute value, whenever you take it, is always going to be a positive number. So we're going to solve this just like we were doing on the other side, and let's see what happens here. Subtract 3 from both sides. Again, I'm trying to isolate that absolute value thingy there. Ooh, I can see there's a problem. Divide by 3, divide by 3. I still have my absolute value term here. But now it says that whatever's inside here, when I take the absolute value, is going to be a negative 1/3. What? Can't happen. Absolute value will never be negative. ABS value will never be negative. So you can just stop right there. You don't have to go any further with that problem. Okay? All right, let's try this one. Same process. We're going to isolate the absolute value. Plus 7, negative 3 times the absolute value of n plus 2 equals negative 3. Divide everything by negative 3. I get the absolute value of n plus 2 equals 1. Oh, this is positive, so it's okay. I can keep going. Whatever's inside here has to equal positive 1 when I take its absolute value. So whatever's inside here has to be 1 or negative 1. So I'm going to set it up just like we did on the other side. Subtract 2 from both sides. N equals negative 1, or n equals negative 3. So that one could be solved. Okay? Here I guess you could say can't happen. All right, let's just look at one more here. Subtract 4 from both sides. Let's see what happens. 2 times the absolute value of m minus 5 equals negative 2. When I divide by positive 2 here to get this by itself, I'm going to get the absolute value of m minus 5 equals negative 1. Again, this cannot happen. Absolute value cannot be a negative. So you can stop. Ready? All right, the last thing we need to talk about. The last thing we need to talk about is absolute deviation. The best way I can explain absolute deviation, it's a whole lot more complicated equation and word than it needs to be. Basically, all it is, let's say you play basketball. And if you play basketball in high school or in professional sports, the basketball has to be blown up to a certain pressure. Probably more in professional sports and college ball. But let's say that pressure is, I really don't know what it is. Let's say it's 23 psi. But they do allow for a little bit of a variation, and they would still allow the ball to be used. So let's say they allow it to be 22.5 or they allow it to be 23.5. So what they're allowing here is a 0.5 deviation from 23. And that's all absolute deviation is. Okay? How far is the allowable amount on either side of that approved number or that given value? So really, I don't even care if you don't use this equation. If you just kind of think about what that means. It says here, the absolute deviation of x from 7.6. That means this is our allowed number, 7.6, is 5.2. That's how far away I can go from it. Can go from 7.2 or 7.6 and still be acceptable. So don't even worry about that equation. Just say to myself, okay, that means I can go this way 5.2 and this way 5.2. So I'm going to do 7.6 minus 5.2. All right, so if I do 7.6 minus 5.2, that means I can go down to 2.4. And if I do 7.6 plus 5.2, that means I can go up to 12.8. So what are the values of x that satisfy this situation? The absolute deviation is anywhere from 2.4 up to 12.8. That's all I want you to think about. How far from the acceptable amount can I go? So let's look at this one. A volleyball league is preparing a 2-minute radio ad, 2 minutes, to announce tryouts. That means the amount they want to do is only 2 minutes. The ad has an absolute deviation of 0.05 minutes. Find the minimum and maximum acceptable times. So if the ad is supposed to be 2 minutes, but they will allow a deviation of 0.05, that means it could be less 0.05 or it could be more 0.05 and still be acceptable. So if I do 2 minus 0.05, I get 1.95 minutes. And if I do 2 plus 0.05, I get 2.05 minutes. So that means the minimum allowed amount is 1.95 and the maximum time, maximum is 2.05. So just think of it of that, okay? They give you an amount and they say you're allowed to deviate this much from it. What does that give you? Okay? All right, now, so that's all for now. Tomorrow you're going to work on these problems in class, okay? You might want to make some notes to yourself on here as to what maybe you didn't understand, and then we can talk about it tomorrow while you're working on it. All right?